Today I'm going to be talking to you about creating the cloud native learning organization. So thank you all for coming. I realized there was a choice of tracks, the 3 tracks you could have been on. So the fact you're here is great. This is the best track, just to be clear, in case you wondered about that. Strategies over there, it's boring. Data's over there, equally boring. Don't care about that. So I'm going to be telling you how to actually deliver on the vision that you heard this morning. We heard a lot of kind of high-level concepts. I'm going to be talking more about how you actually make it happen. I've been invited to speak today by our wonderful team that organised the event because I'm famous for sound bites. I have a habit of coming out with a lot of kind of controversial things. I saw somebody running to the front here. I thought there was one of our legal team going to come and rugby tackle me and take me down. So there may be a few controversial things here. One of the things that I said was this. Cloud Foundry is not exciting. What's exciting is what you can do with Cloud Foundry. Now, you may notice that that's not me in the picture. That is Colin Humphreys, Professor of Metallurgy at Cambridge University. And all of my quotes accidentally get attributed to him online. So whenever I come out with controversial things, it gets attributed to Colin Humphreys. The scary part of this is that there are over 90,000 Colin Humphreys out there on this site. You may see the URL at the bottom, 90,342. So there's an army of Colin Humphreys coming to attack you. But this talk is not actually about me and my army of Colin Humphreys. This talk is actually about learning. And I'm going to talk to you about learning. So I would like to posit that software development is about learning. It's about learning about our users, learning about the market, learning about our customers. And I'm going to explain that. But first, I'm going to take you on a methodology detour to try and explain why it's about learning. So 3 methodologies here: Agile, Lean, and Six Sigma. I presume you've all heard of at least one of these. Who's heard of all of these before? Quite a few of you. Great. So Agile, which we've spoken about this morning quite a bit, the key metric there is responsiveness to change. How quickly can you respond to things that you've learned? How quickly can you change? With Lean, it's about cycle time. With Six Sigma, it tends to be on deviation, minimizing deviation, which is where the name comes from. Can we make sure the next unit, the next item that we produced is 99.9999% similar to the last one? Can we minimize deviation? So I think these aren't actually existing independent of each other. I think these actually represent a spectrum where we are more focused towards learning about our product on the left as you look at it, and a spectrum where we're more focused towards efficiency on the right. So we've heard a bit about bimodal this morning. I think it's slightly misleading. I think it's actually a complete spectrum. And this isn't the full spectrum. There's lots of other data points that would be on this spectrum. It's not just 2 things, it's 3 or perhaps more. So a way to kind of explain this, the analogy that I like to use is cooking. So if you're baking a cake, you tend to bake one cake, you try it out, you see if it tastes nice, and then you might bake another one or a few. But you're experimenting and you're learning. If you go into McDonald's and they're creating a Big Mac, you probably don't want the person who's in McDonald's making your Big Mac experimenting with that Big Mac while they're creating it. You want one that's just like the last one you ate and the one before that. So they tend to be done in large batches. If you're experimenting, you're learning about what the best recipe is, you tend to do it on the agile end of the spectrum. Now I want to further this analogy by saying, if you are developing software, the clue's in the word development, you're probably towards the agile and lean end of the spectrum. If you want to copy software rapidly and create many copies and clones of that software, your laptop has a very good copy command which can do it very efficiently. So if you're developing software, you tend to look at agile and lean methodologies. So in agile, we tend to see things like extreme programming, which we're very proud of working with here in Pivotal. In lean, you tend to see things like Kanban, so you also see parts of that in Pivotal, with our Pivotal way. But we focus towards that end of the spectrum. So having covered that, I'm going to bring us back on track to what we were talking about. So I think If we're thinking about software development, we're thinking about learning, we're thinking about those kind of methodologies. This has been recognized across the industry. So this is a quote. Everyone must be able to experiment, learn, and iterate. This is a quote from a blog from Amazon. This is over 10 years old. So the things that I'm talking to you about today, about software development being about learning, this is not a new thing. Amazon worked this out a while ago. In fact, this is a very, very old thing. So how do we learn? How do we as humans learn? Very basic question. Anyone want to offer me an answer? How do we learn? Right. Okay, let's dig into this. So when I was at school, we learned by scientific method. A scientific method looks like this. You have a theory, use that theory to make a prediction. On that prediction, you create an experiment. You observe what happens in the experiment, and you've learned something. So when I was at school, I had a theory that creating a thermite reaction in a science class was going to be awesome and fun, and everyone would think I was super cool. Some people know what thermite is, they're laughing. So my prediction was that, as I said, if I actually do this in my science class, everyone's going to think I'm awesome. So I created an experiment where I lit a thermite reaction on my desk, and I observed that I was in a huge degree of trouble because thermite is a very hot burning reaction. It burnt a hole in the desk, and I got in a tremendous amount of trouble. So I learned something at school. Now, I've noticed recently that this is absolutely everywhere. And if you're wondering, by the way, scientific method goes back to the Egyptians. So as far back as we can trace human civilization, this is how we've been gaining and acquiring knowledge. And as I said, I've noticed this is everywhere. So this build, measure, learn loop, this is from the Lean Startup, heavily influential book. The idea that you build some software, or you have some ideas, you build some software, you code the software, you measure via your data if your software is making things better or worse. You learn from that, you have some new ideas, and you go around this loop. So this was heavily influenced by another important product book called 4 Steps to the Epiphany. The idea being that the thing that will make your product best is repeated learning through these loops. And the faster you can learn, the faster you will outcompete your competitors. You'll beat them because you're learning faster. Another implementation, the OODA loop. Who's seen the OODA loop before? A few people, okay. Observe, orientate, decide, act. This came about from a gentleman called John Boyd. John Boyd was a fighter pilot in the Korean War. He flew F-86 Sabres, which were technologically a vastly superior fighter to the Russian-built MiG-15s they were fighting against. But they kept losing dogfights, and they couldn't work out why. So it turned out that the Russian plane was technologically inferior in all ways, apart from the fact it could turn faster, it could change direction faster than the American plane. So that was the ability to actually change direction faster, determining success. And that heavily influenced later American planes to be focused towards the ability to turn and react quickly. This is my favorite loop, implementation of a learning loop. This is the Deming cycle, plan, do, check, act, also known as the Shewhart cycle. So Deming was a truly fascinating figure during World War II. And if I hadn't mentioned, this is mostly about military history. Okay, so we've covered Korean War, now going back to World War II. So in World War II, Deming was able to take the building of B-29 superfortresses from, it was 2 weeks to building an individual one, down to building multiple planes per day. He did that by experimenting and learning with new production techniques on the production line. So he did this. So I think if you look at all these loops, all they're really saying is the faster you can iterate, the more successful you will be. That will be the determinant of your success. Like, have you ever noticed how the companies that we're aware of as being tremendously successful in the internet era are the ones that have their fast updating applications on your phone? So if you just look at your phone and see which apps have updated recently and how frequently they're updating, you notice a correlation between those companies and the most successful companies. and the ones that are changing their UIs, the ones that are adding features and functionality faster, are the successful companies. You can't stand still, you have to learn. So also, if you want Colin's top tip to get rich, okay, look for areas where companies aren't learning, go in there and disrupt them. So if you think of industries that we traditionally think of as not very fast moving, where you're getting a bad experience, where you don't see fast iteration, go in there and disrupt them. Outlearn the people that are there. So how can we actually, we as Pivotal, work with our customers to help them plot their learning loop? How do you actually make this real? So a very good effort towards doing this is to do what's called a value stream map. Very simple way to do this. How do you go from idea to delivery? So when the business has an idea of something you want to deliver, what steps do you go through to make that happen? And I'm going to hope that you do some story mapping. You then have engineers working, test-driven development, pair programming to bring those stories to life. They commit code to CI. CI system pushes it into Cloud Foundry. Fairly straightforward. And you've got something delivered. Fairly easy. Then think about how do you get feedback about whether or not what you've delivered is good. So you should be looking at your data on that code that you've pushed. So you've delivered a feature, a story. You are looking at your data. You're getting feedback on that. And then think about how do you take that feedback and create a new idea. So how do you take that data, how do you consider that and learn with the business about a new idea? So now we've created a loop. We've gone from idea to idea. We've mapped in a learning cycle into the business. So just do this with Post-it notes. It's a really interesting exercise to do. On each of those Post-it notes, as to how you go from idea and back to idea again, put times against them. Fascinating to see that. See how long a cycle takes in your business to go from an idea to a new idea that was based upon the feedback of the last idea. It's really interesting to see. So to map this back to the learning loop, have our stories and our TDD and our planning. We pair to actually write the code, push it into a CI system, and out it goes to Cloud Foundry. We're done in terms of executing. We check with our data, and then we have we together collaborate to review the data to make some decisions on that basis and come up with a new plan. So I think a lot of you right now are looking at me thinking, this is all blindingly obvious, Colin. Why are you telling us this? We are doing this. We've been doing this for ages. As I said, we've been doing this since Egyptian time. There's nothing clever about this. So I worked on a project a few years ago, well, about 8 years ago, in which to execute on this cycle took 3 years and £12 million. So it's some insurance software. We planned everything out in minute detail. We bought some land to build a data center. We built a data center on that land. We put servers into racks. We did the whole thing. Built the whole thing from the ground up. It was going to be absolutely amazing. It was going to change the way the world buys insurance. And then 3 years in, real customers interacted with it, and they absolutely hated with it, and the whole thing was canned, and we lost £12 million and 3 years of everyone's time. And a lot of people lost their jobs. So the organization's reaction to that, quite predictably, was to say, that went really badly. So next time, we're going to plan for 5 years. We're going to do it better next time. So that's the fearful organization. And that's what we're trying to move away from. If you execute faster and you learn, you lower your cost of change, you lower your risk, you lower your waste. Okay? And this is where if you execute faster and you have the idea that if something doesn't work out quite as you planned, you've learned something from a failure rather than people losing their jobs, then you build a courageous organization. And the technology that we're building can make that happen. So, where does this go wrong? What goes wrong with this approach? What are the anti-patterns here? So the first one I've just highlighted is water scrum fall. Some of you may have heard of this. So I've seen a lot of projects recently where you're doing an agile approach, which takes you through, we're doing some stories, it's great, got product owners in, breaking things down to small stories. We're doing code, pushing it into CI, we're testing, the test suite all works, everything's fantastic. We can't push to production for 2 years because some other people elsewhere, they're building the production system. So we're doing lots of very, very small iterative development, and that's great, but it's not going to see real users in production for 2 years. So what we've got here is Scrum stuck in the middle of a waterfall process. And you think, well, that's okay. I mean, isn't that the bad old days? People used to do that. But now, obviously, we're cloud native. We've got these amazing platforms. Well, unfortunately not. I still see now, in the past year, this was a talk I saw given about how to use Kubernetes. I'm not bad-mouthing Kubernetes here. I love Kubernetes, fantastic piece of technology. But this was a talk about how they spent about a year taking Kubernetes and turning it into a platform that we consider to be a platform. And obviously, for that time, they're not producing code that's going out into production for users. This was a blog article along a similar line, 1 year using Kubernetes. I love Kubernetes. It's a great tool. Do not get me wrong. But it's not what we consider to be a platform that you can deliver apps with very fast feedback on. So this here, 1 year in production, this article was about how taking Kubernetes, adding load balancing, adding health management, adding a whole ton of things to turn it into a production platform over the course of a year. Now, the list of things in this blog article look remarkably like this list here. So this is one of my colleagues, Bridget, fantastic speaker. She's talking about what constitutes a minimum viable platform. List there if you can't see it: routing and load balancing, backing services broker, infrastructure orchestration, health management, monitoring, recovery, reusable runtime environment repository, log aggregation. We could actually go on and on and on with this list. Things that people had to add in to tooling and build their own to produce a platform. Oh, if anyone wants to take a photo of me pointing at Bridget, and then this can become like the recursive pivotal, and then Bridget can have one of me, and then it can just go on forever, please go for that. I'm trying to get this started, but it's not really working. Okay, so these are all the things you need. And I'd like to say you should stop wasting your time. Okay, these are solved problems. This is being done. Okay, building platforms, it's happened. Okay? So you don't have to build platforms. Cloud Foundry does this for you. Now, that was a fairly long list of stuff, and I'm saying people are obviously out there using various other tools other than Cloud Foundry. Let me give you an example of Cloud Foundry's success to show you just what you can achieve. So this was a blog article I wrote about Comic Relief. I realize there's some people not from the UK here who's heard of Comic Relief. Show of hands, people who I know have heard about Comic Relief, not raising their hands. It's fine. So without showing you all of it, just to give you some of the headline numbers, we took a system that had never worked in production. Okay, so Comic Relief have a donations night once a year. They take in, at that point in time, at the peak of their donations, they take more credit card transactions per second than the rest of the UK economy combined. Okay, but they only need it for 6 hours a year. So how do you build a system that's bigger than an entire economy for 6 hours and then turn it back off again? Okay, it's fairly challenging. So we took that from never having worked properly and being delivered by 50 people to being delivered by 5 people and working with Cloud Foundry. We took that from being in just licensing for the database software that was used, about $12 million a year, to being in total delivered with all the infrastructure and all the apps for £450,000. Okay? These are fairly dramatic changes, at least an order of magnitude, if not more, in each case. And we took it for the first time in running in 24 years to this point. It had failed every single time in production, and it's run for the last 4 years without an outage of any kind. So I'm not saying correlation is causation. I'm just saying since it's been running on Cloud Foundry, it's had no outages at all. So those things are tightly correlated. If you're fascinated by the architecture, because there may be some developers here, some pure technologists, it looks a bit like this, deployed across 2 Amazon regions, and third one here, a VMware. So active, active, active across Amazon EU West, Amazon US East, and a VMware provider in London. So if any one of these goes down, including the whole of Amazon, the whole thing stays alive. So this was done with 5 people, including the apps that were 27 microservices. So quite a change. What I want you to draw from this is not how amazing it is technologically. What I want you to draw from this is, firstly, you may notice this is written by me, and you've been listening to me for about 25 minutes now, so you now know that I'm an idiot. And if I can do this, you can do this. Also, this was a blog article published in 2013 about work done in 2012. Okay, so this is 4 years ago this was happening. This is not new. This has been running in production for 4 years. So if you're worried about getting into Cloud Foundry and thinking, oh, these are kind of crazy new tools, this is not crazy or new. 4 years of production this has been running. So how did we make this happen? Well, a key thing we did, we deployed to production on day 1. We built a very small app and did a CF push to somebody else's Cloud Foundry on day 1 of working with Comic Relief. So getting code to production should never block your flow. Okay, you just CF push it and it works. Now, obviously, Comic Relief said, this is rubbish. This looks like you spent 1 day on this. Go back and do it better. But you're already in that feedback cycle. That's the way to get started. But that's not the end of the story. So, said about anti-patterns. So now we're going to Cloud Foundry. We have apps in Cloud Foundry pushing, and we're continuously delivering to Cloud Foundry, which is great. But we can't stop there. I think continuous delivery is a great set of patterns, but I can see it go off the rails and have seen it go off the rails frequently, because if you are delivering continuously, delivering loads and loads of small features, without looking at the data to see whether or not they're making your services better, you see this feature explosion of things people may not want. So continuous delivery is not enough in of itself. Something it does allow you to do is to move to microservices. So I think we as humans cannot solve large problems. We can solve small problems. What microservices allows us to do is to take big problems and divide them. One of the challenges with microservices is how do you deploy lots of small pieces of software? And that's where if you have a cloud-native platform like Cloud Foundry, you can do that, because it lowers the cost of deployment. It takes it from being perhaps a 3-month exercise to being CF push 1 command. So now we can move to microservices. We can push lots of small units of software. How do we actually do that? So, ladies and gentlemen, I present to you the lazy person's guide to cloud-native microservices. I'm very lazy. I'm going to tell you how to do this really easily, because I think there's a lot of noise out there about microservices. I'm going to tell you just how to do this. So we've got Cloud Foundry. How do we create a microservices application or suite of applications on that platform? So people will tell you you need to read Domain-Driven Design, which is a fantastic book by Eric Evans. It's also a very long book. Okay? So I'm too lazy to read that. It's a lie, I have read it. But if you don't want to read that, scratch Domain-Driven Design, create your microservices, start with 1 service, and then divide by the reasons to change. And that sounds a bit abstract, but when you're wanting to add value into your microservice, you're wanting to add new features or functionality, you'll find you have certain reasons to do certain things. You want to make a change to the users. You want to make a change to the billing. You want to make a change to the address lookup. It will almost divide itself over time. As you're adding features, the reasons to change will emerge. So don't try and engineer a microservices architecture. Allow it to emerge over time. People will talk to you about 12-factor applications. Who's heard of 12-factor applications? Most people in the room. Fantastic. So I'm going to simplify this for you. Do not learn all 12 factors. Learn 1 factor. Okay? The key factor you need to know is do not store your application's state on local disk. You can wait for the rest. The other 11 can happen later. They're like value adds. The key factor you need to enable your application to be cloud native is do not store your state on local disk. That gives you horizontal scalability. That gives you the ability to, if there's an outage, you can just spin up new processes. You get so much value from this one factor. So use services that are external to your application for storing your state. Use brokered services to do that. Okay? So the 12, they're all great, don't get me wrong, but if you have to learn one, learn just that one. Externalize your application state. Moving on, very quickly. So these Netflix patterns, who's heard of these before? Show of hands. Most, if not everybody. Fantastic. So we talk about these kind of cloud-native patterns for building microservices. So they all sound very complicated, okay, and they are. So don't start with all of these. I'm going to cross off all of them apart from circuit breakers, making this very easy. So circuit breakers are a pattern popularized by a book called Release It by Mike Nygaard. It's a fantastic book. Do read that book. The reason you need circuit breakers is that that allows your services to operate independently of each other. So what they should do, if you've got 10 services, any one of them should be able to operate in a way that's good for your users and useful in the absence of all others. It also means they don't denial of service each other if they're having trouble. So it brings a tremendous amount of resiliency to your system. Now, the others that are there, client-side load balancing, config management, service discovery, etc., don't get me wrong, they're all great. But if there's one thing you should take from these, it's the circuit breaker pattern. This will make your site so much more resilient to outages. Okay? So circuit breakers effectively mean that your services, they call each other. If there's an outage of any kind, they don't keep trying to contact the service that's out. They will do the best thing that they can in the outage of the other services. So this is a great, great pattern. Please do go and have a look at that. So that was the lazy person's guide to cloud-native microservices. I really said two things there. Okay, so I said circuit breakers, okay, and I said externalize your state from your application. If you do those two things, you'll get a long way towards being cloud-native. So let's say we do that. So we've got that done. So this is great. So now we're delivering microservices, and we have our data. So I'm also then going to say something controversial. That is not the end of the story. If we are planning, we're pushing things out to Cloud Foundry, we're checking, we're looking at our data to see whether or not we're delivering value. This sounds fantastic. So I think if we do all of that, it's still not quite enough. We need to involve the business. We need to engage with the wider business to see if what we're doing is the right thing. So the anti-pattern that I've seen here with microservices is that you have like a front-end team that are delivering super well, and it's great. But they're focused on how many users can we get onto the website. So then it turns into a Daily Mail style, let's have as much clickbait as we can possibly get. And you were trying to sell hats. The next thing you know, you've got like Kardashians news everywhere, and you're getting thousands of users, but they're not buying hats because your team was focused on bringing as many users as possible, not what the business actually wanted. So when you have all these small teams doing their own things, it can go a little bit wild. So you have to have them feeding back into the business and taking informed decisions with the business. And I think then you come back to true DevOps. DevOps does not mean configuration management. It's been misappropriated. DevOps means theory of constraints, looking at this cycle, working out why we're blocked from executing on this cycle. So I'm going to claim back the word DevOps. It's a great book by Goldratt called The Goal, which was rewritten recently to the book called The Phoenix Project. Okay, these are great books, read them. They're about theory of constraints in these cycles. So, why should you listen to me? Well, my judgment has been questioned many times before. Apparently I lose a lot of credibility saying these kind of things said about me. Apparently I am blatantly misinforming. A little bit unkind. But my favorite of them all was this one, "You're so simple." That's exactly how it was typed. This was alleged at me on Twitter. I said, my only response was, "What about my so simple?" But There you go, because a grammar joke always goes down well. So what I'm asking you to do here, really, is to empathize with the business. So if you haven't tried running a business, it's really, really hard. So I'm a developer, then became a CEO. So as a developer, I had cycles like this. I had red, green, refactor. I would write a failing test. I would then create some code to make the test work well, or to make the test passed, and then I would refactor the code, leaning on the test to make better code, which I could then lower the cost of change on that code so I could add more features, more stories, and go back through the loop. Okay? So as a developer, I had this test suite, I had these fast learning cycles. It was great. Okay? But business people, they don't have this. They have this. Okay? They have Gantt charts. Okay? If you haven't seen a Gantt chart before, it starts at the top left there with overinflated expectations, and it finishes at the bottom right with everyone losing their jobs. Okay, so let's help them. Let's see if we can transform that. So I asked you to not see Gantt charts. I asked you to see series of small learning cycles. Okay, let's change the way this works. Let's think products and learning, not projects and deadlines. Let's change this. And if you're in a large organization, I asked you to become a venture capitalist. Think about a series of small products that you're building, okay? And if they don't work out well, then kill them. If they do work out well, then fund them further, okay? So I was a startup CEO. I was jealous of enterprises, okay? If you want to execute on something, you need people, you need money, and you need customers. And enterprises have all three of those things, and I had none of those things. And yet enterprises are scared of startups, and I find that weird. Why is that? So if you are in a large organization, think about funding a series of small products. The ones that go well, invest in them. The ones that go badly, kill them. Take the people away from the product. They haven't failed. It's the product that failed. Put those people onto the successful products. Okay? A series of products with learning cycles. So how can we as Pivotal help you with this? How do we help you with this learning cycle? So what we do, on the planning side, we obviously have Pivotal Labs. You know, our techniques, agile methodologies, helping you break down your thoughts into small testable features. On the execution side, we have Pivotal Cloud Foundry, getting your code into production. On the check side, we have our big data suite. So you can go and see if your applications are delivering value or not. And last but by no means least, you should interact with the business, as we call it, the business. So what we're doing here is we at Pivotal are building the operating system for organizational learning. And I think that's a great quote. So I'm going to attribute that quote to Colin Humphreys from Cambridge University. Well done, Colin Humphreys. That's it. I'm done. Thank you very much for your time.